This video is designed to demonstrate how to use Stata to conduct a multiple regression analysis. For this demonstration, I'm going to open up the data that we used for Educational Statistics 2 for the intermediate analysis techniques for SPSS. And the data that I'm using is the high school and beyond data. And so we can browse that data, and the variables that we're interested in are math achievement as our dependent variable, with gender, grades in high school, motivation is here, motivation and parents' education, parents' education as our independent variables. Now, one of the assumptions of multiple linear regression is that the variables in the analysis are linear related. And one way that we can examine this is to produce a scatter plot that gives us a visual idea of how these variables relate to one another in a linear fashion. So I can put in math achievement, motivation, do grades in high school, parents' education, and gender. So if we look at this scatter plot matrix, we can see some linear relationships between our dependent variable and our independent variables. So for example, in this case, as we have low motivation scores associated with low math achievement scores, and high motivation scores associated with high math achievement scores. So we have somewhat of a linear pattern. Same way with math achievement and grades in high school as well. You'll notice that for gender, we don't have a linear relationship. And the reason that is because gender is categorical. So you have either male or female. So in other words, what you're going to have is the scores on all of these other variables for males and for females. And so in this case, that's why we have this dichotomy or this dichotomous pattern. So we're going to go ahead and look at the relationships more precisely. If we go to Statistics, Summary Tables and Tests, Summary and Descriptive Statistics, and go to Pairwise Correlations, we can get the actual correlations between math achievement, motivation, grades in high school, parents' education, and gender. And if I go to the Stata output window, we can see what the relationships are like. So the correlation between motivation and math achievement is 0.316. Between grades in high school and motivation or math achievement is 0.504. Parent education and math achievement 0.389. And gender and math achievement minus 0.30. So there is a relationship. Some of them are smaller than others. And we also see there's a negative relationship. And what this typically means is because we have a categorical variable, that one group has a higher mean math achievement score than the other group. And in this case, if we were to calculate the mean for male and the mean for females on math achievement scores, we'd find that males have higher math achievement scores than females. And so this has to do is the way that the data is coded. And so males are coded 0 and females are coded 1. So now we can see that there is a linear relationship, at least some type of linear relationship between the dependent variable and the other variables. And we can go ahead and run the multiple regression analysis. So we're going to go to Statistics, Linear Models and Related Linear Regression. And then our dependent variable is math achievement, and our independent variables in this case are motivation, grades in high school, parents' education, and gender. And so now we can go ahead and run our multiple regression analysis. And you can see that in this case, we see our model sum of squares and the residuals. So this is the explained variance in math achievement by these 4 independent variables. This residual is the unexplained. And we can also see that our R-square is 0.459. So what this suggests or means is that 46% of the variability in math achievement scores is explained by the linear combination of these independent variables. And we could go further and look at each of these variables. These are the coefficients. In other words, these are the betas, and they're unstandardized. And we can see that they're all significant. In other words, they all significantly contribute to explaining variability in math achievement. Now, we can't compare these coefficients directly because motivation, grades in high school, parents' education, and gender are measured on somewhat different scales. So if we want the standardized beta coefficients, we have to go back up to linear models and related, linear regression, and then under reporting we can check standardized beta coefficients. Now we could have done that to begin with, but we wouldn't get the 95% confidence interval. And it's really nice to have that when looking at the significance of each of those coefficients. So I can go OK. And notice that now I have my standardized beta coefficients and I can compare these. So what we can say is that grades in high school certainly has the largest coefficient, followed by gender, followed by motivation, and then parents' education. So these can be compared. The unstandardized coefficients cannot. Now, one of the other assumptions of multiple regression is that the residuals are random, that there's not a relationship between the residuals and the predicted values. And so to understand that, we can go to regression diagnostics and we can go to residual versus fitted plot. And so we can see that these residuals, in other words, the difference between the actual value in the data set and the predicted value based on our 4 independent variables, that there's not a relationship, that it's random. In other words, we don't have high predicted values and residuals being related to one another and low predicted values and residuals being related to one another. There's not a pattern. This pattern is random. The other thing that we can do is look to see if the residuals are normally distributed. In other words, is the error normally distributed? And so to do that, we go back here and we go to post estimation. So we're looking to estimate a statistic after this analysis has been done. And so I can go to predictions, and I can go to predictions and their standard errors, leverage statistics, distance statistics, etc. And so I can launch that, and I'm going to name my variable residual. And so I just want the linear predicted value, okay, based on the linear predicted value. And so again, remember, the residuals are the difference between the predicted values and the actual values in the data set. And I can go OK. And I'll cancel that, and I'm going to go back up here to Browse. And if I go to the end of my data, you can see here are the residuals. So it created a new variable for me. Now, what I can do is I can go to graphics, and I can get a histogram of the residuals. Oops. And I can submit that. And so I can see that my residuals look fairly normal. So I've met that assumption of having normally distributed residuals. So I hope this has helped. In other words, I hope this has helped for you to understand how to conduct a multiple regression analysis using Stata.